Hello, GED students. We are here to do a math ability video on substitution. So substitution is one of the three crucial algebra skills. There's three things really you need to know in order to be a strong algebra student, whether it's for the GED, the high set, your college algebra classes. If you don't have a base of these three skills, you're going to be in trouble. And those three skills are substitution, simplification or simplifying, and solving. Those are three things you've really got to understand. And so what happened is I could not sleep last night. I kept waking up in the middle of the night, dreaming and thinking about substitution. I had been sent all these practice problems from students in the past few days, and there were different problems from all across the board from different tests. And I realized that the key skill in almost all of them was substitution. Again and again and again, it shows up in all these different contexts. And, I'm always looking for ways that I can quickly boost you guys' scores. I hear all the time, Kate, I can't remember all this. It's too much. There's no way I'm going to pass this test because I study this thing, I forget. I study that thing, and then I forget the last thing. And I feel so stuck. One skill, so many problems. Substitution is going to come up in a bunch of contexts. And so what I would like to do with you here is look at what substitution is, but then look at all the different GED style, high set style problems in which it comes up. And at the very end, we will do a college algebra example as well. Great practice. Let's really strengthen those muscles. If you're a struggling math student and you just can't keep it all straight, this is for you. So first off, I just keep using the word substitution. What the heck am I even talking about? Think back to your elementary school classes. What did it mean when you had a substitute? A substitute came into your class in place of the teacher. They replaced the teacher. Nobody ever had a substitute and their regular teacher there. The substitute came in when the regular teacher left. We have the same kind of idea in math. In math, when we have a substitution, we are trading out one thing for another. But it's important that you understand that that trade is always of equivalent values. When you're substituting, you are trading one equivalent value for another. Now, you might be saying, Kate, there you go again with the words I don't know. Equivalent just means equal, guys. So the thing has to be equal. And this is a huge thing that we use in math all the time. In fact, you've been using this idea of trading out one equivalent value for another, one equal thing for another. You've been using it like way longer than you realized. In fact, you started using it before algebra. You've probably been using it since elementary school. Let me show you an example that you probably already used substitution. You didn't even know that that's what you were doing. Here is an example of a type of problem that you might see on the first 5 of the GED math test, but it is a pre-algebra problem. All it is, we can see some numbers here and some operations, some things to do with those numbers. Like there's a minus sign, so that's an operation. It tells us what to do with the 5 and the 2, subtract. And so this is a expression that has more than one operation, right? There's some multiplication, there's some subtraction, there's an exponent. And so I would need to rely on my order of operations in order to simplify it. So right there, looking at this, if I were asked to simplify this, I'd say, oh, I need the order of operations. Now let's think about what you do when you simplify an expression like this. What you do is trade out one equivalent value for the next. Let me show you what I mean. So if you were doing this problem with me in class and you were a struggling student, I'd probably pick up another color so that we could really focus in on what do you do next. We would rely on the order of operations, of course, as we always do when we have more than one operation going on. And I like to use the acronym GEMMA to remember it. I know you guys like PEMDAS. I hate PEMDAS. I have a whole video explaining why. If you want to go check it out, it's called The Real Order of Operations. But I use GEMMA. So first thing that we're supposed to do is we're supposed to start with any groupings, insides of groupings. And indeed, I can see that I do have a grouping in this particular problem. It is inside of a parentheses, but groupings don't have to be. And I can see that I have this grouping. So what's the very first thing you would do in a problem like this? Well, you would do an act of substitution. You would replace 5 minus 2 with an equivalent expression. A simpler one in our case, because we've been asked to simplify. We're replacing 5 minus 2 with something that means the same thing. 3 is the same. It's equivalent. It's equal to 5 minus 2. And then what's the next thing I always ask you to do when we're doing order of operations expressions? Well, I ask you to drop down everything that you haven't used yet. So we substituted 3 for 5 minus 2, but I want the rest of the expression to remain the same and have the same meaning. And so we always drop, keep that 3, keep those parentheses, keep that square. And what I see now is I see that this second line that I've written is equivalent. It's equal to the line above it. Why is it equal? Because the only change I made, let me say it again, the only change I made was a substitution. I took 5 minus 2 and I replaced it with a number that means the same thing, that's worth the same amount, 3. Now, we keep moving on like this. Each line, you're just trading out. You're making a substitution. Next step after we do groupings was to tackle any exponents. The E in my little Gemma stands for exponents, and I do see an exponent here. And again, I'm going to pick up a different color here so you can see. Here is my exponent, 3 squared. And when I simplify, I'm literally doing a substitution. I'm going to trade out this number 3 squared for a simpler version of it, yes, but something that's equivalent. It's equal. So 3 squared is equal to 9, right? Because 3 times 3 is 9. So I substituted 3 squared for 9. Now I'm going to keep those parentheses there, only because I can see that that 3 was shoved up against parentheses and I need some kind of indication of what they're doing there. So when two numbers are shoved together, the only thing between them is parentheses. We know that they're multiplying. So there's only multiplying left to do. So obviously I will multiply now. But let me just finish up my order of op for those of you guys who were like, hey, what the heck? She never finished. M is multiplication and its inverse, which is division. And A stands for addition and its inverse, subtraction. But yeah, multiplication is all that's left to do in this expression. And you know what? I should be putting equal signs here because that's the idea. Each line is supposed to be equivalent to the next because all I'm doing is making a substitution. So now 3 times 9 is 27. And I've substituted this whole thing. This whole thing is worth 27. It's been replaced. You may have never thought about it before, but every time I teach simplifying expressions, I'm really anal about the way you write your answers. I want every line to be equivalent to the one before it. The only way to do that is to use this substitution idea that each line is identical, but you're just trading out one piece for an equivalent piece. And I never thought of it like that before. Never once in my life until I woke up in the middle of the night last night, you guys. See, I'm more than a little obsessed with helping you all with math. Okay, so simple example. We've seen this before. We've done it, even though we didn't realize it. And maybe we argued with our math teacher a little bit. Why do I have to show my work? This is why. This is this lovely substitution principle we're using. Let's look at even more examples of how substitution comes up in algebra. Okay, here's a very typical GED style question that would freak students out. But what I want to show you is it's actually a really easy problem. Looks scary, works out easily if you understand substitution. Again, it says evaluate the expression 2x squared minus 3y squared. And all of a sudden my students, especially, those with learning disabilities are going, oh my gosh, there's letters. I don't know what to do. I can't do algebra. Why'd they bring letters into math? Guys, don't freak out yet. Keep reading. Look what it says. 4x is equal to -3. Bingo. X is not a mystery. Let me say that again. X is not a mystery. I know what X is. X is equal to -3. That means that anytime I see an X, I can use substitution. I can replace that X with -3 and then keep reading. And it says, and Y equals -2. 2. Once again, anytime I see a y now, instead of calling it y, I can call it -2. I can do a substitution. If you know two things are equivalent, you can trade them out. And we know they are because of those equal signs. So let's use that to our advantage. So let me take that expression. And if you're a struggling student, I just highly recommend that you just write the expression on your paper with no changes first, or else you're more likely to drop symbols. So I'm just going to copy it out. And now I'm going to do my substitution step. Again, if you're a struggling student, let's use 2 colors like we did on the last problem. We'll use the same color for the things that stay the same, but we're going to use a new color for our substitution. So here we go. I'm going to keep my number 2 the same, right? We want each line to be absolutely and totally equivalent, equal to the next. And the way that we're going to do that is the only changes we'll make is trading out 2 things that are equal. Next thing I have in this line here after 2 was x. I do know something that's equal to x. What's equal to x? Well, up in my problem, it said that x was exactly the same as it's equal to -3. That means anytime I see an x, I can trade it out for -3. Now watch what I do, guys. I'm going to do that with parentheses. Really good rule of thumb when you plug in numbers, especially negative numbers, to use parentheses. Sometimes they're not necessary, but they'll never hurt. So it's just a good habit to develop. And they are necessary in this problem. So 2 times -3 there, that's what it means, that they're squished together. Now, I traded out, look at what I traded out. I traded out the x for this -3, but I have to keep all the other symbols the same. Let's do that. I still need a square, I still need a minus, I still need a 3. But I don't need the y anymore, right? Because I know what y is. Y is not a mystery. As our problem set up here, y is the same as -2. So I can do that substitution. I could trade y out, this mystery, for this known value. And again, I'm going to use parentheses since that 3 and that y were shoved up next together and they're multiplying. And also because of that exponent there, really good idea to use parentheses when plugging in 2 exponents. And if you're like, what is she talking about? I'm talking about this little floating number, this little 2. Make sure that goes on the outside of the parentheses. And now take a look at this. You might be saying, Kate, that looks just as disgusting as the last thing. Yeah, it doesn't have x's and y's, but it has negative numbers and exponents, and I hate those. And I say, well, but once it looks like this with no letters, you can pick up your GED calculator, plug the entire expression in there. All you needed to be able to do was that lovely act of substitution. So let's do it. I'm going to have a 2, and then I'm going to open parentheses for -3. Guys, use parentheses. Don't use a regular times sign. And then I'm going to press the x squared button to get that little square. And then I'll type -3, open parentheses, -2, close parentheses, and I'll square that again by pressing the x squared button. And I get 6. Literally the only skill, besides using your calculator, that came up in this problem was the skill of substitution. Looks scary, but all it was a simple trade out. Can you trade one thing for something else that's equal? Nice to find an algebra problem that's easy, guys. Let's go look at another application. Okay, here's a kind of gross looking problem that I think would stress some students out. So first, let's just read it together. It says evaluate the function. That's nice. Same language as before, evaluate. But I think this idea of a function would kind of scare students. And then I can see my function. Now, this part, guys, this doesn't say f times x. I know it looks like it with the parentheses. That's what we're used to. And that's what we usually do with numbers. Like if I wanted to say 7 times 5, I'd write it like that. But when I want to multiply letters, all I do is just shove them real tight together. Like if I wanted to say f times x, I would just write fx. This notation here says f of x. It stands for a function of x, which seems like a weird way of saying, it's just kind of like saying an equation with x in it. So we're saying we have an equation with x in it, and here it is. But if that's freaking you out, guys, f of x is just a fancy way to say y. And so again, I never even thought about it that way. I've explained that in 1,000 videos, but hello, just calling it y is an act of substitution. F of x and y mean the same thing. So if it's less confusing for me and I just trade out f of x for y, I'm saying the same thing. Now, that being said, look at what they told me. They want me to evaluate this whole big ugly fraction function, which is probably freaking you out, but they want me to evaluate for x is 3. X is equal to 3. Guys, as soon as I see that, I cheer. It's not really algebra anymore, except for that really simple act of substitution. Every time we see an X, we can trade it out for this equivalent value. X is the same as 3, so why not just call it 3 and make our lives easier? So I see an X here in my fraction, and I will replace it with the 3. And now I still have my square, my minus, my 3. Okay, and then I'll keep my fraction bar, and then on the bottom of my fraction, I have the 5 and the minus, and again, there's an X. See it? I know an equivalent value, 3, and there it is. And you might be freaking out like, oh, okay, that didn't get any easier. Look at this gross fraction. But again, I would say to you, you guys, you can use your TI calculator to plug this entire thing in. Now, some important things to know though, you should be in math print mode. In order for fractions like this, these kind of complicated fractions with numbers inside of them and operations inside of them, if you want them to type out the way they look here, you need to be in math print mode. So go ahead and hit the mode button, arrow down to math print, hit enter, and then hit clear to leave that screen. And then you'll be a happier person. Now that you're in the right mode, the very first thing you want to type into your calculator when you're doing these complicated type of expressions is your fraction bar. In order to get a fraction bar, you are going to type N over D button in your TI calculator. And then you should see your cursor, which is that little black box, blinking on the top of a fraction. And once that's going on, you can type what's in the numerator of your fraction. So I'm going to open up parentheses, type 3, close parentheses. Then once again, I'm going to use that nice X squared button, minus 3. Now, make sure after you get that typed up there, we don't want to be in the top of the fraction anymore. We want to be on the bottom now. So what you're going to need to do is you're going to need to hit your arrow key. Arrow key is that big dark gray key up there, and it has 4 little arrows. Well, arrow down so you can get to the bottom of that fraction. And then there you'll be able to type 5 minus 3. And then you can press enter, and you'll see the final answer is just 3. So once again, it might have looked gross. It might have looked scary. We had this notation we're not used to, f of x notation, this disgusting looking fraction and these letters. But really, the only skill we needed was substitution. And then, of course, our handy dandy calculator skills. Lovely. 3 GED style problems now. 1 skill. Okay, let's take a look at this geometry problem. Now you might be saying, Kate, I thought you said this was an algebra skill. And good news is pretty much all the geometry on the GED is formula sheet based. Formulas are algebra. So therefore, if we get strong in these algebra skills, we don't really have to know too much about geometry. We could just use our algebra skills. Same skill. So many points to gain. Take a look. It says, find the circumference of a circle with a radius of 14 millimeters. Well, you get a formula sheet when you hit up the GED. Google it, guys, if you don't have it. Okay, just Google GED formula sheet. You'll be like, oh, I get this when I test. Yes, you do. And you take a look at it. The second section there on the formula sheets is the perimeter section. And if you look under that, you're going to see the circumference of a circle formula. It's an interesting line there. There's 2 formulas. You see C is 2 pi r, or C is pi d. And then it has this weird little semicolon and then a pi and then this wavy equal sign, which means approximately equal to, by the way, guys, 3.14. So that's what you're going to see on your GED formula sheet when you look at this, and you might get real frustrated and lost. But once again, I want to say to you, all you have to do is substitution. So let's look back up at our problem. It says, find the circumference of a circle with a radius. Can I just point out that radius starts with R? A radius of 14 millimeters. So right now, I know 2 ways to talk about this radius. I could call it R, radius, or I could call it 14, because the radius is 14 millimeters. So take a look at this first formula I wrote down. Notice that it has an R in it. That's the one I want because I know R. So I could trade out R for this known value, this 14. So that's the one I'm going to work with. So let me just copy it down so we don't panic. Same thing I want you to do when you're solving any problem that involves a formula. Just copy it out first. Just copy it out exactly the way it looks, because it's really easy to make a mistake if you skip steps. And now I'm going to perform my substitution step. I'm going to trade out any symbols for known values. My life is about to get a lot easier. Now, I don't know what C is, because C stands for circumference. And look what the problem says. It says find the circumference. So C is the thing I'm finding. It's still a mystery. It's going to stay C. And that's equal to, I keep my equal sign and my 2. But right now I can start trading. Look back up at that line. Notice that they told us something about that symbol, pi. Even if you've never seen that symbol before, you don't know it's called pi, it makes you want to puke. You're so super scared of it. We know about, that's what that wavy equal sign means, about what pi is equal to. Pi is equal to 3.14. The GED gives us permission to use this rounded number right in that very line. So that's what we're going to do. Whenever we see pi, we're going to substitute, trade it out for this value 3.14. Notice I use parentheses again because it's shoved up against that 2. They're multiplying. And then pi isn't the only thing I can trade out. I also know my radius. It's known. It was given to me up in the problem. I have an equivalent value for R. R is 14 millimeters. And so I can substitute out, I can replace R with 14. And then look again. This might still look scary to you because of the C, but I'm just speaking in a complete algebraic sentence. I'm saying the circumference is all this math. And guess what? That math doesn't have letters in it anymore. So once again, I can pick up my GED calculator and multiply it through. So I'm going to do just the right-hand side. 2, open parentheses, 3.14, close parentheses, open parentheses, 14. And I get that the circumference of the circle is about, it's about because I put in that 3.14 is only approximation, but that's okay. You don't need to use the wavy equal sign. I'm super anal retentive because I'm a math teacher. And it's about 87.92. And it would be millimeters, but you don't even have to know that for the GED. So once again, all I needed to be able to do was plug into this formula, and the formula was given to me, and pick up my calculator. I mean, seriously, there's another example where just being able to substitute and use a calculator is golden. You're golden. Now, these formula problems do get a little trickier. There's ones where after your substitution, you're going to need more algebra skills, the skill of solving as well. Not going to do that today because we haven't done the solving video yet. We're starting with the substitution. But again, remember I said 3 big skills from algebra: substitution, simplifying, solving. If you can do those 3 things, you're good. So we've been substituting. And then the calculator work we've been doing here is simplifying. Look at us. We're hitting 2 of those 3 big algebra skills. But I've got more examples. Let's look at another one. So for guess and check methods, substitution comes in handy. And here's the good news. A lot of times you'll forget all your different steps for algebra, for solving these kinds of equations or those kinds of equations, for doing word problems, inequalities. I mean, students will just get all in a muddle. So one of the things that I always teach when I'm doing test taking skills is working backwards, using a guess and check method, taking the answers and basically seeing if they work. A problem like this would probably freak a lot of students out because look, there's a fraction, there's some maybe parentheses, stuff I don't know how to do, looks like scary, but I have some possible answers. I have some possible values for X. You know, if I'm saying solve, I'm saying, well, what could X be? Well, you only have 4 options, right? X could only be 3, -3, 2, or -2. So it's not going to take you that long to guess and check if you forget your algebra. And literally, guys, this is not the only kind of problem I could work this way. I sat there and thought about it for 5 minutes before I wrote the problem because I could think of at least 15 GED style examples that I could use a guess and check method on, from word problems to inequalities to quadratics to something like this. So there's lots of times you could do this. Okay, this is just one example. But what I could do here is I could just substitute in these answers and see if they work. So basically what I need to ask myself is if I put a value for X into this side, will it really give me -6? I don't know. Let's check it out with my first number and let's just see. And so I'm going to do that lovely substitution again. I'm going to keep this side the same, except for the X. I'll trade the X out for this value of 3. And notice again, I did it in parentheses. Don't let it freak you out because there's already a parentheses there. My little 3 got traded out. And again, we can see the only change I made here was what once was X is now a 3. And then I want to see, is it really going to give me -6? If it's a solution, then this left-hand side should give me -6. So once again, I can pick up my lovely GED calculator. If I don't know how to multiply fractions, I can type a fraction into the calculator. Let's do that. I'm going to type n/d to get that 3/4. So 3 on the top. Arrow down on the bottom to hit 3/4. Now notice you have a black cursor blinking down on the bottom there. You don't want to keep typing on the bottom, okay guys? So now it's important to use your arrow key again, that round arrow, to arrow right. And now you should see that you're blinking next to the fraction instead. And now you'll be able to type the rest of your expression. So open up parentheses, 8 parentheses 3, close parentheses, minus 24. Close parentheses, and see what it gives you. Guess what it gave me? This whole thing gave me 0. Well, is 0 equal to -6? Of course it's not. And so this didn't work. A little guess and check, and it didn't check. So let's guess one of the other answers. I'm just going in order, guys. If you have a good feeling about one, you could do whatever order you want, but I'll try -3 next. So again, I'm going to substitute, which means I'm only going to trade out values that I know are exactly the same. Everything else will stay the same. So 3/4 and 3/4, parentheses, parentheses, 8, 8. But I have a guess as to what I should substitute in for X. I'm thinking X might be -3. Let's take a look. Plug that in using parentheses, keep my minus, keep my 24, keep my parentheses, and then I'm trying to see, is that going to be equal to -6? I don't know. Let's take a look. Once again, I can plug this entire expression into my calculator, and my calculator can simplify for me. So n/d, 3 on the top, 4 on the bottom, and then arrow right to get out of that fraction, guys, before you keep typing. Open up parentheses, 8. Open another parentheses, -3, close parentheses, minus 24, close parentheses. And I've had students who get so lost in the symbols, guys, that they have to look at just one number at a time, like slide their thumb across this expression to make sure they type it into the calculator correctly. If that's you, no shame. And I get -36. Well, guys, is -36 equal to -6? Of course it's not. This is not a solution either. We're just going through here. We're guessing and we're substituting in our guess to check our answer. Let's try the next one. Let's try 2. We're going to move a little faster here. So 3/4 times 8 times 2 in parentheses minus 24. Close that parentheses from up there. I want to know, is that going to be equal to -6? I don't know. Let's try typing this entire thing into our calculator. Okay, n/d button, 3 on the top, 4 on the bottom, arrow right to get out of the fraction, open parentheses, 8, open parentheses, 2, close parentheses, minus 24, close parentheses. And that does give me -6. Guys, is -6 equal to -6? Heck yeah, it is. That checked. That guess worked. So now you might say, Kate, that would take me a while. That seems a lot longer than solving the equation. Yeah, guys, I'm not saying lose all your other algebra skills. If you remember how to solve an equation like this, go for it. Do it by all means. But what if you forget? You're going to forget some stuff on your test. You're going to be nervous. Guess and check is like one of the best methods in our toolbox when we're like, I don't know what to do. And in algebra, guessing and checking usually involves substitution because you have possible solutions. Go plug them in, see if they really work. And like I said, I could probably come up with 15 questions from the GED that I could use this guess and check method with substitution on. So, I mean, nice. One method, tons of problems that you could work with it. Okay, I promised you a college prep example. So if you're just prepping for your GED and you're not worried about college right now, you can just skip this one. You've gotten all the GED style examples that you need, but this kind of problem might show up in your GED prep sources. Some of them do teach it, even though you don't really need it. You can use the last thing we did, guess and check, for these kinds of examples because it's always multiple choice on the GED, but in college, these won't be multiple choice. And so one of the methods we use to solve something like this, so just FYI, what this is called is systems of equations. And what I mean by that is that I have two equations, two variables. A system of equation has more than one equation because it has more than one variable, more than one letter. So you can see here I have two equations and two letters, x and y. And the way that they're asking me to solve this is with the substitution method, meaning I'm supposed to trade out something for something it's equal to. And take a look down here. Notice that I have y all by myself in this equation. So that means I could call y, or I know what it's equal to. It's equal to all this jazz. So y could be called y, or it could be called 10 minus 3x. You might say, well, why do I care? Well, I have two equations, right? So if I know two names for y, I can substitute that other name for y into the other equation. So that's what I'm going to do. Now, okay, guys, this is for college. This is for college. You can feel free to turn off this video if you're not prepping for college yet. But I'm going to start with this equation. X plus 2y equals 15. And I am going to make the trade. I am going to do substitution. Instead of putting y, I'm going to put this other name for y. Nothing else will change. Take a look. So I still see my x, I still see my plus, I still see my 2. You might be thinking, why do I still see my x? I don't have another name for x. I don't have somewhere where I know what x is equal to. And so I just have to keep them x. But I do have another name for y. I can call y, or I could call them 10 minus 3x. Remember that good habit I was talking about where you substitute in with parentheses? That good habit is crucial right now. I'm going to take that whole funky thing, 10 minus 3x, and substitute it out for the y. Now, nothing else should change from the line above. So I should still see the equals. I should still see the 15. And now you might say, hey, Kate, that got uglier than before. But I actually say, hey, no, that's not uglier. That's prettier. And there's a reason why I like this better. It only has one letter. I'm going to say that again. It was crappy before. I had an x and a y. Like, how can I ever find out what x is if I don't know what y is? How can I ever find out what y is if I don't know what x is? When I had two letters, I was in trouble. But now I only have one letter. It's just x's. And so even though it looks a little uglier, I can actually do the work to find out what x is going to be equal to. And so I'm going to need some more algebra skills. You're going to see me use the other two s's I've been talking about, the simplifying and the solving, in order to figure out what x is equal to. So let's do it. Let's simplify. First, I can see this 2 is shoved up against the parentheses, so I can multiply here. So positive 2 times 10 is positive 20. And positive 2 times negative 3x is negative 6x. And again, I've substituted. I've taken this part of the expression and substituted it with equivalent values. But I need to drop everything I haven't used yet. So I haven't used this x up front. So I'll drop that down. I haven't used the equals and I haven't used the 15. And let me just use that color so you can see it. How about blue? So I took this entire thing here and substituted it out for this entire thing here. And see how there's no other changes? Everything else is the same. Now, I see some more simplification I can do on the left-hand side. X and negative 6x combine. You can certainly do it in your calculator if you're one of those who struggle. But if I have one x, that's how many that is. If you don't see a number out front, okay, guys, that's one x. Say an x is like $1. I have $1. I spend $6. I take away $6. I'm going to end up negative in the whole 5x. Now I've substituted. I've replaced the 1x minus the 6x with the negative 5x, but I haven't used the plus 20 and I haven't used the equals 15. Okay, now it's time to start solving. So you would have all three of these skills by the time you were doing this. So I'm going to start working to get this x alone by moving backwards. I'll subtract 20. Whenever I make a change, I do it to both sides. And let's see, adding 20 and subtracting 20 cancel. I have negative 5x, and then that's equal to, and again, I'm doing a substitution, whether you think of it or not. 15 minus 5 is equivalent, it's equal to negative 5. I'm going to trade that out for that simpler value. And now I'm almost done, but x is not alone. I need it alone. And so I'm going to divide out that negative 5 multiplier, and multiplying and dividing by negative 5 cancel, and I get this lovely value. X is left on the left-hand side, and again, I'm going to substitute out. I'm going to take and simplify negative 5 divided by negative 5 and write the answer there. So what is negative 5 divided by negative 5? It's just 1. So now this is very interesting. I have x is equal to 1. And I use the substitution method to figure this out. I replaced y with this jazz into my other equation. But remember, I had two variables. I had two things I didn't know. I didn't know what X was and I didn't know what Y was. And you might be saying, Kate, do I have to go back through that whole entire process now to figure out Y? Well, no, because now I know what X is equal to. X is equal to 1. It's still an act of substitution, but it's much simpler because I can just take this equation, Y is equal to 10 minus 3X. You might be saying, which equation do I take, Kate? It actually doesn't matter, but I'll take the second one because it looks easier. And now I'm going to do a substitution. Now that I know what X is, I could put it in and figure out also what Y is. So let's do that. So Y is going to be equal to 10 minus 3. And guess what? I'm going to do a substitution where I once saw X. I'm going to substitute in that known value. X is 1. So I can trade out an X for a 1. And now, lazy girl that I am, I'm going to pick up my calculator again, plug this expression in. So 10 minus 3 times 1 is 7. So now I know that Y is 7. And now I have the solution to this system of equations because I know what both the values are. X is 1, Y is 7. And I use substitution. So from pre-algebra, where we were just simplifying these kind of like order of operations expressions, all the way up to this more complex, like Alg 2 college Alg skill of solving systems of equations, we see that that base skill that I'm using again and again and again and again is substitution. Do you want strong Alg skills? You've got to understand the concept of substitution. Guys, if you enjoyed this video, if you learned something, you should thank my patrons. They are the ones who give monthly to make sure that I can keep on creating these materials for struggling math students. Super thankful to all my patrons who are both light and salt, coming in at $15 a month of support. Thankful as well to those of you who sprinkle salt, $9 a month, and you can support GED learners across the globe. And for those of you who shine a little light by giving $3 per month, you guys are such an encouragement to me as well. So blessed by your regular committed giving. For those of you who've given me cups of coffee over the last year with your one-time donations at $5 a piece, I am so blessed by you as well. Like literally every time I get a cup of coffee, I just am so encouraged. I show my husband the phone and I'm like, look, what I'm doing is worthwhile and people agree with me. And so I need to keep doing what I'm doing. Ooh, I'm crying now. Thank you for the coffee. If you have any questions about substitution or any other GED math topic, or hey, HiSET, college, we were talking about all of them today, be sure to drop those in the comments. I will do my best to answer them, and happy learning, you guys.